So this application is using a database called as retailer billing DB. Here we use just one table from that category table. Apart from category table, we have so many others also in that. The other tables are, we have a product table, we have their customer table, then we have sale table, item sale table. So like that, we have different tables in that. So let us finish that database designing part. Let us finish all the database designing. So in the retail billing DB, we had here one table. The table name is category table. We had just one table, its category. We need to make other tables in this. One table is called as category, is available for us here. Apart from category table, we should be making other tables as well here. So other tables are going to be here. New table we should create. You can create a new table either by using this designer. This is called as designer interface. With the help of this you can create a table, or else using the new query editor window you can make. This is exactly what, using the designer you can make table, or else you can go to new query editor window. Using that you can make. But always use the new query editor window. With that you try to type a command. Instead of using just designer interface, instead of using GUI, graphical user interface, you can use this particular command window. Using this new query editor window, with that you can do it. First of all, we need to open database. In the SQL Server, to open database, we use a command called as use retailer DB. So retailer billing DB we should put. Even here IntelliSense is available for us. Select it and execute this one. So what is happening here now? It's creating for us. It's opening the database. Now the database is opened. Once database is opened, we can even look into the database table. What are the parts of the database table we have to see? That means what are the columns are available in this? You need to see that. For that purpose, you can use a procedure called as execc sp underscore help. We use like this. Followed by, we can use the database name, a table name. It is TBL category. You can use, with the help of this, you can find out the file structure, table structure you can find with this. Select and execute. It gives the table structure. In the bottom you can see the structure of the table. Category ID, category name, category level, then followed by whether we have any identity element. We have identity element, that is cat ID, seed value is 1000, increment is 1. Like this you have. Then followed by, you have here any primary key, foreign key do we have here. Primary key PK cat ID, foreign key FK cat ID. Like this even we have the primary key. Table is referenced by foreign key. This is the foreign key we have here. FK underscore cat ID. With the help of that we are referring. So like this, here we have different constraints. A default constraint, a foreign key constraint, a primary key constraint. Like this, we have here few constraints associated with the table. What is a constraint? You have an idea, Sandeep?
Say that again. What was the constraint?
Table field constraint. Primary key, foreign key, then similarly default constraint. Then we have check constraint. You have idea of those?
I'm not sure. Like, can you go over the foreign and primary key? I always get hung up on those ones. Okay. I know the very first one would be the. I think the worst. If the element comes first, I think is the primary key, or I don't know.
No, not like that. Right. Primary key, first of all, something like this it is. You have a primary key. Primary key meaning is primary key equal to column. It is first of all not null plus unique. This is called as not null plus unique is called as a primary key. Meaning is what here? In that column there should be some value, and whatever value you have in that column should not be a existing value in some other row in the same column. You may be having number of rows. So every row contains say equal number of columns. Suppose in a particular row, under particular column you have a value, then similarly in the other row, under that column, the value must not be repeating, and the column also should not have any empty value. And in such cases, that is called as a primary key constraint. Primary key meaning is here, in the concerned row, in the concerned column, the value must not be missing, and at the same time, whatever value you have in that, it must be unique among the rows. You may have some 100 rows. So in that in that particular column, the value must not be missing. Another thing, the value must not be getting repeated with some other column, in some other row. So like that, we have there primary key constraint. Primary key meaning is it should not be null. At the same time, it should be unique. When you have data like that, that's called as primary key. Primary key meaning is it should not be null. At the same time, it should be unique there. The value must be unique. At the same time, the value must not be missing. That is called as a primary key. You take any organization, every employee has an employee ID, correct? Every employee has an employee ID. So, without an employee ID, no employee can be working with us. At the same time, no two employees' ID is going to be same. So, that is called as their primary key. Similarly, take departments. A department ID you have, a department name you have. No two departments can have same name, at the same time can have same department ID. Every department should have an ID, at the same time they should have unique ID. So no two departments should have the same ID. Like employee it is here. In the case of employee ID must be distinct, at the same time it should not be missing value. Such things are called as primary keys. Okay, sometimes what happens, I give an example. Here employee you have, here department you have. So there is one employee and there is one department. Suppose you have few departments. Departments are maybe like accounting. Take like this. One is accounting. One is here marketing. Okay, one is administration. Probably you have here 3 departments in an organization. So one is accounting department, one is marketing department, one is administration department. Suppose you are trying to recruit an employee. When you recruit an employee, the employee must be belonging to any one of the departments. So employee should not be belonging to more than one department. At the same time, when you recruit an employee, the employee must be belonging to any one of these departments only, either accounting or marketing or administration. If you try to put an employee, within a department which is not existing with us, something like R&D input, it is meaningless. Or you try to put it to production. Since there is no production with our organization, so if you try to put an employee into production department, there is no meaning. So here it is violating the referential integrity. That means EMP-ID must be maintaining any one of these department names only in that. If you look at EMP table you may have here something like this here, EMP-ID. We have here, then followed by department take, department just you take. So whenever you enter values here, you may enter something like 101. Department should be here accounting. Like this only you should have here. Okay. Similarly, 102 you may have null value here. See here, 103 you take. You can put something like marketing here. This way you can be entering data. So whenever you try to add a department for the employee, either you may not be adding any department or existing departments only you should add. But where these departments are available, they are available with the department table. So whatever entries you have in the department table, any one of the entry you can attach with the DEPT of the employee table, or else you can be missing it. So when you miss, it means what? You recruited employee, but so far you haven't allotted any department. Like that you can think it. But when you allot any department, only existing departments you have to put. This is called as actually referential integrity. With the help of primary key, foreign key, we link like that. Understood, Sandeep here? Concept?
Yeah.
So like this you are going to use primary key and foreign key. Now further we continue here in the retail billing DD. Next table we try to make. And to see the structure of the given table, you can use EXEC, SP_help, TBR category. With the help of that, you can see the details of the category table here. Now let us come to the other table here. So other table let us create. The table is going to be here product table. We need to make product table. So what are the columns we have in the product table? If you look at the conceptual model, we have an entity called product. Okay, so what you have in this product ID is available here. Similarly, product name is available for us. Then other thing is what here? Product ID, product name, then price is available for us. At the same time, we have here product ID, product name. Okay, here I remove totally pure body ID I just put. Okay, so product name, product price. One more thing is here cat ID, because category ID is required here. Every product should be coming under particular category. Therefore, we put here category ID. Like this, we need to have a table. Then product ID is what? It's a integer value. It can be a number which can be getting repeated, and it cannot be getting repeated, which must be always unique. But auto-generated. We can use identity element. With the help of that, automatically we can generate that number. We can't enter that because that can be giving us confusion. So automatically ID must be generated for us. For that we use their identity feature. Then we have product name. We need to enter product name. Then price we need to enter, followed by category ID. So category ID must be one of the existing category IDs which are part of the category table. So when you link the product table with the category table there. So here this cat ID is going to be referring the category table cat ID. That is called as basically referential integrity. It's called as referential integrity. So when you talk about integrity, you have data integrity as well as referential integrity. In the case of data integrity, whatever data you try to insert should be valid data, should be falling in the given range. With the check constraint, we see that. With the help of the primary key foreign key relationship, we maintain the referential integrity. So referred data, if it's not existing in the table, in the primary key table, the data, the row will not be added, row will be simply rejected. So like this, you can be maintaining certain constraints here. Primary key, foreign key constraint meet for referential integrity. For that purpose, we use it. Now create the product table. So for creating product table, we use create table command followed by TBL product, put like this. Then followed by here, we specify a product ID, product name, then it is here price of the product, followed by we put the category ID. So put it prod ID. This should be here integer data. Okay, integer data we can put, and this is here identity we put. Identity we can put here. We can start with the 10,000. We can put with 10,000 and we increment by 1. We can have up to, in this, if you want to have only 5 digits, up to 99,999 we can have here. Overall 80,000 products we can have with this. Product ID, INT, identity, 10,000 comma 1, then followed by we put here product name. This is here varchar of 100. Up to 100 characters we have. Varchar 100 meaning is it is going to be variable length character. If you enter only 10 character, it takes 10. If you enter 50, it takes 50. If you enter 100, it takes 100. So like this variable length field that is going to be, number of characters can be changing depending on your entry there. So every table under this column may not contain only 10 or 20 or 30 or 40, depending on your data, how much you entered. Based on that, it's going to contain that many characters. So this is what exactly product name, varchar of 100, then followed by price. We have here price of the product. Price of the product we have here. Then price followed by here we put it as float data. This is price is going to be float here. Then unit also you need to put here. Unit we put here. This is again we need to have, in the case of unit, some kind of varchar only required for us. Varchar followed by this is some 50 we can put here. The next thing is here cat ID. Cat ID, here it is. Cat ID is INT, put like this. So first of all, we defined here these columns. We are defining these columns. Product ID is required, product name is required, price is required, unit is required, cat ID is required. So like this, we have here total 5 columns in this. This is fine, but there are no constraints right now. there is no primary key, there is no foreign key constraint we have here. Even in the case of price also, suppose you have a retail outlet, you are going to maintain a minimum price for every product. So when you enter a product, you should have some minimum price at least for that. Suppose if you maintain retail outlet, the minimum price of any product is going to be something like 10. You can put something like 10.0 minimum price. Whatever product you add, it should be taking minimum price. So I use a concept called as minimum price also here. So if you don't enter any price, automatically it should take there something like 10. It should take. So default constraint we can use for that. So here try to use price float. Default we cannot use. So we have to enter, but with check constraint we need to take it. Now here put constraint, followed by here try to specify PK, then this is prod ID, put it product ID. What is the name of this product ID? This is product ID. Constraint is what here? Primary key. Put primary key. Then after this you can put a column name. What is the column name in this? Product ID. Okay. Then after that we need to go with the foreign key. So foreign key once again we specify here constraint. We put it FK. Then this is FK underscore. We need to write it as here. Again category ID. Put like this. Then this is here foreign key. So what is the column in the current table? The key what you want to refer as foreign key, it is cat ID. It should be referring here. Put references. What table this is? The table is TBL product. Table is going to be TBL product for us. Then here we put in the TBL product. Sorry, it's not TBL product. TBL category. So there also it is cat ID. Like this we make it. So this way we can be here defining the new table. Table name is product table, a product ID, product name, a price, then unit is varchar 50, then cat ID INT, that is constraint TK underscore product ID, primary key, product ID, that is product ID, that is. Then next constraint FK category ID. So that is going to be foreign key. Here cat ID. In the current table cat ID is foreign key. Same time, in the same way, it's going to be referring the TBL category cat ID. Whatever column you refer in the foreign table, that must be primary key, then only we can refer it. If it's not a primary key, you can't refer. Definitely it must be a primary key in the foreign table there. So this is foreign key. What is the foreign table here? Foreign table is going to be TBL category. From the current table, we are referring the TBL category. So in the TBL category, cat ID is going to be here for us a cat ID is primary key in the TBL category, but in this current table, it's a foreign key. So it should be foreign key. Like this, we created here a TBL category. Then let us create one more constraint. I was talking about check constraint. Put here constraint. Constraint. Then write CHK. Then this is price. I put like this. CHK price. Then here CHK constraint. CHK price, put it as check here, then try to set the condition here. So what condition we put here? Price greater than or equal to 10.00, put like this. So minimum it must be 10. If it's less than 10, it does not accept there. Minimum price is going to be 10. When we try to enter less than 10, it does not accept. So this table is called as the product table, which contains 4 columns: the product ID, product name, price and unit, and cat ID. There are 5 columns in this. We have a product ID, product name, then price, then cat ID, and we use a constraint here TK underscore prod ID, primary key prod ID, that is. So this is going to be containing a column called as product ID, that is nothing but here primary key. Then similarly foreign key is going to be cat ID, which is going to refer the TBL category. So the TBL category cat ID is the say primary key, but here this is going to be foreign key. Like this we are going to be linking up both the tables. The tables are here what? TBL product, and one more thing is here TBL category. So TBL category is going to be a foreign key table, whereas TBL product is here the current table. And TBL category is called as primary key table, and TBL product is going to be foreign key table. So like this, we are going to link with the cat ID both the tables. This is giving us actually required referential integrity, whereas CHK price is going to give us here domain constraint. With the help of that valid data and the data which is falling in the range you can take. If you try to enter price less than 10, it does not accept. So minimum we made it as 10 like this. This is called as here HF constraint. Understood this here, the table structure? Any questions on this?
No, no, right now.
Mansoor, do you have any questions on this?
No, I'm fine. Thank you.
Mahmood, any questions on this table here? Okay, I did not create so far, I just written the syntax for it. Now I want to create it. So select like this, and after that try to create it. Always try to use commands like this instead of using graphical user interface. Try to do with this. It is going to be giving you complete command over the code. When you use graphical user interface, what is happening internally you can't understand. So initially when you start practicing, you must use these kind of things. Once you get some command over it, you can be using the graphical user interface. So like this, try to type always the required commands. Now first of all, check for the syntax. Syntactically it's correct or not, you can check. Syntax is correct. Now execute this. Command completed successfully. Now we got two tables in this. There are two tables in this now. We refresh. When we refresh, we get one more table also in this. One is category table, other one is product table. When you expand here, you get columns, cat ID, cat name, cat level, super cat ID. In the same way, if you go to product, you find here columns, product ID, category ID. Category ID is foreign key, product ID is going to be primary key. Like this, we create a table. Even you can see here the ER diagram. Here you can call this as ER diagram. We can generate the ER diagram for this. New database diagram we try to make here. Select both the tables. Now add. You get both the tables in this now. So the tables are like this. It is category table and other thing is here product table. We have a category table and product table. So here this is the product table is referring the category table in this. It is referring here the category table. So what it is referring here? Cat ID is being referred. From the product table, we refer cat ID. This is called as here one-to-many relationship. For one category ID, there can be number of products. That means what? Under one particular category, there can be number of products. Like that. Similarly, when you take a cat ID, under a given cat ID, there can be number of subcategories. Like that also you can be coming to conclusion. Whenever you take a particular category, under that category there can be number of subcategories. Similarly, when you take a category, under that category there can be number of products. So like this, we are in fact, we are referring the category table from the product table. So we link two tables with the help of the primary key as well as foreign key relations. With the help of primary key, foreign key relations, we have linked here. So like this, the tables we created. TBL category is containing cat ID as primary key and super cat ID foreign key. Similarly, whenever you look at the TBL product, in such case, what is happening? We have a product ID as primary key, cat ID is here foreign key. The cat ID is referring the cat ID of the TBL category table. TBL category is foreign key table. TBL product is primary key table. When you select here, it's showing the relationship also. When you click here, it can show the relationship. It is showing relationship in the bottom. Now select here this one, move over this one, it can show relationship. Even here also it can show relationship. Between the same table, what type of relationship we have, we can find out with the help of that. So like this here, we created the two tables. one more thing, later on when we do ASP.NET based web application, we are going to do mini project with the ASP.NET. There we are going to use same database. The retail bill in DB only we use. So using the web interface, we can be adding categories, we can be adding products, then we can make the checkout something like shopping cart kind of thing we can make. With that people can be checking out, they can be that means they can buy the products. So that we make, in fact, for that purpose, same database we are going to use. This is the database we are designing now. Same database we'll be using. Mouse is not well, so due to that, giving some nuisance. Fine. So here we created the one more table called as TVL product. Now what else we need to make here? We need to make here a unit table. Unit table, I mean we need not make, otherwise we can enter manually. If we want to enter, we can enter, otherwise we can leave it like that. Unit table. So why we use unit table here? Unit is basically meant for entering whether it is automatically gets filled. We don't fill this one, it's going to fill automatically because we have taken identity, this one. It is going to be filling automatically. When you make an entry, automatically the value will be taken there. Cat ID we need to we need to refer from the we need to enter that manually, we have to enter, or else if it's GUI, existing categories we can choose from the drop down list. With that we can be entering it. So we have to enter manually this one. You need to remember the cat ID, we have to enter manually this particular thing, cat ID. In the case of graphical user interface application, definitely you can have a drop down list kind of thing. So in the drop down list, existing category names come, you can pick a category name, with that it can be getting entered. Appropriate cat ID can be getting entered. So like that we use. Normally using GUI we do it.
Okay.
Now next thing, here it is going to be, this is for making the, here it is product table we created. Okay, we created product table here. After this, now we have to create a customer table. But here see, when you look at product table, in this product table, what content can change from time to time? In the category table, nothing changes there. Cat ID, once you enter, once you add category name, it's not going to change anything. But when you look at product table, certain content can change from time to time. What is that content which can change from time to time? Look at the product table, you have product ID, product name, price, unit, then cat ID. So from this, what can be changing for the product? Time to time. Once periodically it is, once for every week or 10 days, 15 days, 1 month, 2 months, like that. What content can change from that? Does the product ID change? It does not change.
Can you change the price?
Yes, price only changes. From time to time, price can be changing. Okay, when you change price, here price will be getting affected. But I want to find out in the given year, how many times price has changed. From what date to what date, what was the price I want to find out. How to find that? Here try to understand once more. Ma'am, try to understand please here. I have a product table. In this product table, I have product ID, product name, price, then unit, cat ID. This is containing current price of the product. Correct? Whatever current price it is, when we update, current price we are going to put there. But during the given period, say for example in 2015, right now it is month May. From January to month, sometimes the product price has undergone changes here. So how it was fluctuating, how the price was changing. So you need to sometimes require that information. From what time to what time, so and so price you had. So like that, what was the period actually? So like that, you want to find out price. So how you find out the price? With this table definitely you can't get. Can you get with this table the price?
I guess no.
So then how we maintain that?
Uh,
Because we require information in the information systems, people require it. Correct, Mansoor?
Yes, that's right. So you need to know the price, right?
Yes.
The price is, yeah, the price is in the product table. So in the product table we got the price.
Yes, but
And the
it gives you
unit.
current price. No, you get always current price only. Right now, this is month May, correct? But see,
Yes,
in
that's
the January you had one price, in the February you had one price, in the month of March you had some other price, in the April you had different price. How to track that information? Where the information is available for us right now? It's giving you current price. As soon as you update, previous price is totally changed there. You cannot track with this table the previous prices. Can you track with that?
yeah. With the date we can track it.
But where is the date information? Where we could? There is no date information in this.
Uh, like like a system date.
No, but there is no date here. You don't have any date here. He may put changed date. Okay. He may put the date. Whenever the price is modifying, that date only you have. That means current price, when it got modified, you have information. But what was the previous price, you cannot get with that. Can you get?
We can when the price is as you mentioned, that the price is modified, then we know that the which prices are modified. Just we can check
Yes.
all the
I
prices.
I want to find out even previous prices also. How many times price has been changed for the product? What were the previous prices? I want to find out. Which product price is modified, you can find out that. That's fine. But how many
Yeah.
times the product price has been modified? You take a particular product, when price is getting modified at that time, definitely you have impact on sales. There may be more sales, there may be less sales. You want to, in fact, analyze that. How are the sales for the product? So when you increase price, what is happening with that? When you decrease price, what is happening that you want to analyze? In the business, definitely we need to analyze. So if it's performing well, then in that case you can keep the product, otherwise you can throw away the product. When it's not doing good sales, why we keep simply the product with us? Correct. So therefore we need to track how the product was behaving. When price was fluctuating, how it was behaving, we need to find out that. How can we find out that? Initially we thought we require 5 tables. One is what? Product table. Then other thing is what here? A category table. Then customer table or client table. Then other thing is here sale table, item sale table. But now the requirement slightly changing here. After once I finish this, the client says, I want to track even the price information, how price was changing from time to time, how it was changing, when it was changing, how the sales were. They want to identify. How can we get that? One more thing
can you
also you see, people may buy first product. After 10 days, up to 1 month, you may give a time to replace that or to return the product. Okay, right now for product you have certain price, say some 10, the price is 10. So tomorrow what happens? By paying 10, they might have bought a product. They have taken the product away. So after a week, after that purchase, after a week, what happened? Price has been doubled. Now it is 20. Okay, after 20 days, the person who bought the product comes back and is returning the product and he demands price for, he is demanding his product price back. He paid 10, but if you look at current price, it is 20. Do we pay 20 to that person?
No.
Understood the difficulty here. What is the problem we face with that? If you maintain only price like this, definitely we have a problem there. Therefore, to track all such information, we require another table called as product price table. We need to maintain product history table here. So let us create one more table called as create table. Then this is here product history. I call it as product history. Then in this, I want to maintain product history ID, product hist ID, put like this. This one is going to be int, or we can take somewhat bigger, long type of data we can take. Then it is here int, identity we take, identity we can take here, followed by 1 comma 1 we can put for this. This is the type of data, is going to be long type of data, we take it. So this is what big int, it's not long, we need to take big int, identity 1 comma 1, we use like this. Then after that, this is going to be primary key for us. So here itself at the column level, I declare primary key. Primary key can be declared at the column level or at the table level. You can declare it at the table level or you can declare it at the column level. In the previous case, we declared at the table level, but now I am declaring at the column level. You need to declare primary key at the table level whenever the primary key involves more than one column. Of course, it's not involving in the previous case more than one column, but just I was showing you the difference. How you can declare at table level, how you can declare at column level. I am declaring primary key at the column level as far as product history is concerned. As soon as you define the column name, then if you put the primary key, that is called as declaring primary key at the column level. At that time, you don't require a specific name like constraint fk category ID. Automatically it will be taking the constraint name here in this. But when you declare it at table level, definitely you must put a name like constraint fk underscore pk underscore prod ID. You kept like this. This is declaring the primary key at the table level. This one is declaring the primary key at the column level. At column level, I am declaring it. Now this is what product hist ID, big int, identity 1 comma 1. This is called as primary key here. Next thing is what we require here, product ID also, which is going to be primary key now. Product ID, and this is here int we put. Okay, this one is going to be integer, and here we must put it as not null. Definitely it should not be containing a null value. It should not be containing a null value. Product ID, int not null. The next thing here, it has to be the price. Price we put, price is going to be float, here we take. Price is float here. Then after that, we create here modified date. dt modified, put like this. dt modified, date time, take like this. It's going to be dt modified, date time, we are going to put like this here. Even default value we can set here. Default, this is here, get date. So get date we can take with help of this, the table can be created. This is going to be dt modified, date time, default get date we take. After that, we need to go with the foreign key here. We need to create a foreign key now in this. What can be the foreign key here? Product ID is going to be foreign key. Constraint. So this is fk product hist ID, and here it is product ID followed by what is the column name? The column name here it is. Okay, sorry. This is foreign key. I put, and here column name is going to be prod ID here in this, and it has to refer references. What table that is? The table is going to be here TVL product. Now in this you have here prod ID as the column. Like this you have here a primary key foreign key relationship between the history table as well as product table. We have like this. So we created third table in this. We are creating a third table here in this. We can have total 3 tables in this. If you come to this, okay, one more table has come for us. Now total we got 3 tables. So how the tables are related, you can look at this. TVL category is linked with the product table and product table is linked with the product history. That means the given product can be getting modified number of times and that information is available with the product history. So as soon as you add a new product or as soon as you modify a product, data must be coming into product history table. But how data automatically comes? User may enter data. Need to dock it. Okay. So user may enter data, user may modify product price, or user may be adding new product. The user bothers about entering data only into product table, not into product history. So as soon as data is entered into product table, it should be getting updated in the product history table also. How we can make that?
Can you say that again?
See, you enter data into product table, you added a new product. So user is bothered about adding product to product table, but every time user will not add to history table. If user is forgetting to add to history table, that means user has to type two times commands user have to type. One is entering data into product table, other one entering data into product history. Due to some reason user forgets entering data into product history table. So you lose the history information in that case. Correct?
Yeah.
Getting here, Mahmood, my point, what I am saying?
Yeah, I understand what you're saying.
So suppose you add a new product. As soon as you add a product, it should come into history table also. But user may be entering into product table, user forgets to enter into history table. What will happen in that case? Mansoor?
We not I think we not enter the in the product table and the history table, because if the history table after such a period it goes to the history table. That's why it's my thinking. It's my thinking that it goes to the history table, and the foreign key we can get that history table. That if we need, we can get that data.
No. What I'm saying, you add a new product. When you add a new product, what is happening? Data is going to product table, correct?
Yeah, that's right.
But so when it's going into product table, automatically it should go to product history table also.
That's right.
But how it goes? I just add only to product table. It should not automatically come into product history table. As soon as you put any data into product table, it should come into product history also. Automatically it should come there. Similarly, I modify product there. As soon as I modify, it should be coming into product history also automatically. How you can make happening? When you put data into product table, automatically it should be getting updated in the product history table. How you can make that?
Okay, I might be wrong. Can you link these tables together? I mean, the third one that you talked.
They are linked already. They are linked. You can see the database diagram. If you look at this, the tables are linked here. Category table, product table, history table are linked already.
Okay.
So here we use now TSQL programming concepts. See, as far as TSQL is concerned, we can write stored procedures, functions and triggers. We have a concept called trigger. With the help of trigger, as soon as you add a product or as soon as you modify a product, automatically it will be entered into product history table. Getting my point here? As soon as we enter here data into product table, it should be entered into product history table. That we can do with the help of the triggers. You can write a trigger. With the help of trigger, you can be making it. It's possible with the help of the triggers. As soon as you add a product or as soon as you modify a product, it is going to be performing some triggering action. With the help of that, product history table will be updated automatically.
Yes, that's right.
So we should write some trigger now. You can write a trigger. So triggers normally we should not write, but sometimes because product modification is not a regular phenomena. User does not modify. Only administrator from time to time they modify it. So therefore, there is not going to be any impact on the users, because it will not be becoming slow, because once in a while you do it. When you perform operations once in a while, at that time you don't have much impact. Therefore, you can write triggers. With the help of triggers, you can be managing it. So where we write trigger, for the TBL product we have to write trigger. Triggers can be DML triggers we have. There is a trigger called like DML trigger. After insertion, after updation, after deletion, you can write it. When you add a product, when you delete a product, or when you similarly insert a product, here you can be writing trigger. But for deletion, we don't do anything, because once you enter data, we never delete. The data we are not going to delete at all. So the data we don't delete, because deletion is going to lead. Deletion gives us referential integrity problem, because you may be selling a product this month. Next time you may not be selling. So if you think that the product is we are not selling, if you delete, if you think that may be wrong, because few years before or few months before you had a sale of it. As long as your business is running, you need to maintain that product information also. So when there was product, how much profit you made with the product, you need to analyze from time to time. Therefore, history data always you need to maintain. It's very much required. So that's why there is no question of any deletion. You may not be using the data, but deletion we should not do. Deletion is going to be giving us so many problems like referential integrity problems. Therefore, don't do any kind of deletion. So you may not be using data, don't use, but never delete any data. So only with the here insertion and with the updation, we need to write triggers now. So we have to write a trigger in this. Here write create trigger. Then here trg followed by insert product on what is the table name, TBL product we put, TBL product after insert. After insert, as we put the begin, then here we keep end. Like this, we put the code block first of all. Create trigger, trg insert product on TBL product after insert as begin. And whenever you go with the triggers, for triggers, the two tables are going to be available. So as far as triggers are concerned, you have two temporary tables available. One is called as inserted, other one is deleted. When you update data, at the time, both inserted, deleted is available, and in the case of insertion, only inserted table is available for us. We have inserted table, and in the case of updation or deletion, in the case of updation, we have two tables. One is inserted table, other one is deleted table. Because updation is nothing but deleting existing data, adding new data. So you delete data, then you add new data. That is nothing but updation. But in the case of insertion, what exactly it is? Only one table, it's called as inserted. Inserted is available for us. So therefore here we write create trigger, trg, insert product on TBL product. After insert as begin, then here we need to define the required variables. First of all, we need to declare few variables. If you look at the table, what are the columns we have in this table? The columns are going to be product history ID, automatically we get. Product ID we need to track from this. And price we need to track. Date modified we don't enter, automatically it comes. Therefore we require here only two columns. We require only two columns, therefore take those columns here. First of all, declare a variable. Declare a variable within a TSQL block, we can declare like this. Declare @ symbol is required in the case of SQL Server. When you work with SQL Server, with the help of @ symbol only, you can declare variables. First thing is here, product ID, put like this, and this is what exactly int. It's integer data. Okay. Then similarly, declare @ this is exactly price, and we call it as float. This is what exactly float. Here we put it as float data. Now we need to retrieve data for these variables from the table. From the table we need to retrieve So for that purpose, we write like this: select @ product ID equal to what we put here, prod ID, comma, then @ price equal to what we put here. This is going to be price from inserted. Inserted is nothing but a temporary table. From inserted table, we are going to take it. Data we are taking from the inserted table in this. From inserted table, which is nothing but temporary table, it is available with the TBL product. It is available with the trigger. The trigger name is TRG insert product and TBL product. So with this trigger, it is available for us. Okay, we select data into this. Then after that, we have to insert this product ID and price into the history table. In the history table, now we need to put here, write if condition. What do we write? If product ID, if PROD ID is not null, if it is not null, in such cases we try to insert data, otherwise we don't insert. Right here, insert into table name is, insert into table is here TBL product history. Put like this, product history. Then here what columns we put, that we need to specify here. First thing is PROD ID. The next one here it is price, we put like this. Price we are going to put, then here values set like this, @ PROD ID, and other thing it is here @ price. Like this we can be setting it. So whenever product ID is not null, in such cases we insert, otherwise we don't insert. And this is called as a trigger. We declared here two local variables. Declare, this is here at PROD ID INT, declare at price float. From the database, from the table inserted, it's a temporary table. From inserted table, we are retrieving values. What values we retrieve here? First thing is product ID, second thing is price, into the appropriate variables. Local variables we declared here, into them we retrieve values. Whenever we retrieve values, if product ID is not null, in such cases we insert, otherwise we don't insert. Like this, we have written a trigger here. Let us try to parse and compile the trigger. What happens? Let us see in this. Check for the syntax. Syntax is correct, then execute. Command successfully executed. Okay, now we take this. After that, once again paste it, but this time we make it as this. We are going to make this TBL update product we put. On TBL product, after update, this is here it is going to be update. Like this we put. After update, same we declare like this. Once again we try to do this. No modifications, in the same way we do it. Just try to once again execute. So two triggers are created. One is for inserting product into product table. One more is going to be updating the product information. So in such cases, data comes into which table? Product history table. In that, it's going to be coming for us. Just refresh it. We have two tables, three tables totally: category table, product table, and other one is product history table. Okay, so like this we have written two triggers. One is TRG insert product, other one is update TRG update product. There are two triggers associated with the tables here. If you expand table, you can find here the triggers. You can look at the sorry, not with this. This is with the TBL product. Okay, triggers. You see, we have two different triggers in this. One is TRG insert product, other one is TRG update product. So we have written here two different triggers on the product table. As soon as you insert a new product or as soon as you modify an existing product, what happens? It is going to put into concerned table there. Like this here we have done. So the tables are what? A category table, a product table, and other thing is what here? A product history table. Like this we created here 3 different tables. They have different purposes. So like this we created here 3 tables. And whenever you develop any application, you have to be carefully making the database. It may take little time, more time, but you have to make it perfect. So in the future, you should have less problems and only few problems you should be having. You cannot make totally problem free everything. Definitely there are going to be problems, but try to make only few, try to get only few problems. So if you carefully drop everything, carefully if you plan and proactively if you think, then in that case you have only few problems. Now even product modification, the price history also we are going to get in this case. When the product price is changing, you can identify from what time to what time the product price has been changed. So like this, we now accommodated 3 tables in this. We have 3 tables in this. Now let us try to insert some data into product table. First of all, see the data in the category table, what data is available for us. Select start from TBL category. Take like this and try to look into this particular table. What data? Okay, execute. You have data like this. Under fiction, we try to insert some data. Under category fiction, let us try to insert data into product table. Whenever we look into product table, what columns can be added here? First column is a identity element. We need to enter here product name, price and unit. Along with that category ID we need to enter. So therefore try to enter here. Insert into TBL product. So column names we need to specify here. PROD name. Then this is price. Next thing is unit we put, and other thing is here cat ID. Like this we can set. Then followed by here values. Put like this, and what values we specify here. I am hard coding the values here. Going to hard code values. Product name I want to keep here. This is series 1. Put like this here. Followed by here the price I want to put. So price I would like to put here. Price I should put like 15.00 here. Units are going to be numbers. Okay. Then cat ID I want to specify this as 1003 because under fiction we are trying to put it. So like this, trying to insert data. This is what exactly varchar. So therefore I should put like numbers here. Like numbers I should put insert into TBL product. Like this I am trying to make it. Check for syntax here. If syntax is correct, we can execute. Now what happened? One row affected message you are getting. That means as soon as we add it into product table, it comes in the product history table also. Let us come into the history table, try to see data from this. You can see here product history ID, product ID, then price we get here. So, and date modified we get like this. Exactly when we are modifying here, you are getting data. So price as 15 we get now here in this. Okay. Now let us try to modify the product data here. So product history, product IDs, how much? 10,000 we had. If you look at this, the product ID is going to be 10,000. So therefore let us try to modify the data. How we modify? You write update. So update TBL product. Then here write set. What do we write here? Set price equal to, here it is 20. We just put set price equal to 20, followed by here 20.00. Then here where condition we put where prod ID equal to how much it is 10,000, put like this. Now with the help of this we try to update the table. Execute. The table got now updated. Once again let us try to see the data from this. It is showing now second entry also. In the first case 15, in the second case 20 it is. So we insert it into product table, but automatically product history table also modifying this. You can find out here DT modified, on what date exactly the price has been modified, at what time also it can show. One is at here 7 minutes, the other one is at the 9 minutes, it's updating. So like this we maintain here the history table. Any questions on this, Sandeep?
Not right now.
Okay. Mansoor, you have any questions on this?
Why these two entries on the product ID 1000? Because it should be one in the table before.
No.
When you update is two, right?
Yes. Because history you need to maintain here. This is nothing but history. See, it is today's date, that's why you get 2015 file like this. It is not once, it should be multiple times.
Okay.
Because how many times product has been modifying, you have to find out that.
Okay. It's not modified the one, one, but is also entered two. Okay, that's makes sense.
No, product is getting modified only once. In the product table, it's only one entry. Price is modifying. But on what date exactly product has been modified, you need to track that information.
Okay.
Suppose you take price modify some 5 times during 5 months. So on what date exactly modified, you need to track all that information. So when you have information like this, so for how many times product has been modified, what was the previous price, you can identify.
Okay. Yeah, and second thing is in the TBL category, I just like to know that there is a primary key point itself. What that reason? If you go to the
Yes.
database diagram.
Okay. Yes.
Yeah, this one table category.
Yes.
You see the table category is the primary key point that cat ID itself.
No. It is the super cat ID.
Oh, okay. It's category or super category. Okay.
This is between the super cat ID and cat ID, because the super cat ID is going to be a category also. Something like you take employee table. In the case of employee table, you have an employee-manager relationship. Correct? An employee is managed by an employee only, but that employee is going to be manager. So in the employee table itself, you have manager ID as well as employee ID. Even you are a manager, but still you are an employee only. Correct or not?
Yeah, that's right.
So in the same way it is cat ID, super cat ID. A super cat ID is going to, a super cat ID is going to be referring the earlier category ID. Something like this here, we are seeing, let me come to the, this one. Okay, so whenever you come to the data here, I may try with category table. In the case of category table, take for example comics. Comics is what? It is one of the book categories. But what is the super category for that? Books only, that is. So therefore, comics are part of book. It is something like employee-manager relationship. Same thing we have here. Here a category and subcategory. Subcategory should be having a main category. If you take comics, it's referring books there. Similarly, if you take fiction, fiction is also going to refer the books. Like this, it's going to be a fiction is also a kind of book. Comics is also a kind of book. So comics is subcategory, whereas books is going to be super category. Fiction is a subcategory, books is going to be super category. So to have relationship here, we are maintaining like this. Subcategory is referring actually category ID. When you try to put a value under super category ID here, existing category IDs only you should put. The category which is not existing, you cannot put there. So like this, we refer the same table, a super category ID and you have a category ID. Super category ID is nothing but it's referring actually the main category. If you look at the 1003 fiction 1000, so 1000 means what here? It is under books. Fiction is under books. Comics under books. But as far as footwear is concerned, you don't have any super category for that because that itself is actually at 0 level. That means it's the main category. Above that, there are no categories. Like this, you can be identifying subcategory as well as super category.
Okay. Okay.
So, I mean, whenever you design the databases, we need to think so many things also. So you have to be little bit domain expert. At the same time, you have to be expert with the commands also. This is all you get with experience. As you practice more and more, automatically you get all those ideas. Because we got exposed to industry for so many years, because of that, we did many things like this. That's why it looks like simple for us now. But when we were doing, we struggled a lot like this. Like you probably. Reason, you don't have much exposure. Because of that, they will look little bit new to you. But these become very simple as you, progress in your career.
Yeah.
Mahmood, any questions?
No, thanks.
So now the same database we are going to use with some web application also. On the same database we are going to work with the web application. Tomorrow further we are going to be working with with data adapter, how to write back to database we look, and further we work with the data set and data table. 2 more days we work with the ADO.NET. Then after that we start working with the ASP applications. Active server pages. So there we talk about HTML, then CSS, JavaScript. Then that is going to be some real application development. So far we are exploring the C# features. The features of C# we explored so far, but we are going to work with some kind of real-time applications now. They are going to be related to web applications, for which you have to be ready with the HTML, CSS, JavaScript. Just try to go through HTML from W3 schools. HTML, then CSS, and one more thing is here, JavaScript. You have to know about these. And the HTML, you have methods like post method, then get method. What are these? Try to understand. So in the W3 schools, a lot of information is available related to web part. Just go through that.
Okay.
Are we planning on just briefly going over them, like in one session, or?
Which one? No, it takes time. We discuss about HTML in detail, with CSS in detail we discuss, with JavaScript also we discuss in detail, but just go through them. We discuss in detail. They can take many sessions.
I thought this was, I thought we were just doing the, like, C#. I know we were doing...
No, C# only, but not only C#, we work with ASP.NET also.
Oh, okay.
Because ultimately you need to develop applications. C# is behind. It is behind the technology. So ultimately you need to use with some technology. With ASP.NET, with Windows applications, with MVC, you need to do with all those things. Because
so if you think we're gonna spend like a week on each one, you think you're saying we still have like 4 more weeks to go?
Yes. No, see, this may be it's flexible in fact. If you require more time, you can spend more time. Ultimately, you must become proficient to some extent. That's my intention, Mahmood. It's not that only time is not constrained, in my opinion. So we may take little time more, but you have to become proficient in this.
Okay. Well, there's a possibility that I'm gonna start watching the sessions in the morning because when I watch them my time, it's late. You know what I mean? So instead of watching them late after I come back from work, I'm just gonna come back from work, do whatever I have to do, and then I'm gonna wake up an hour early or hour and a half early, watch the video before I go to work, so I don't have to do it when I come back home. Because when I come back home, it's stressful when I have a long day at work and then I come home and for an hour and a half or 2 hours, and then by the time I finish, it's already 10 o'clock.
Yes.
That's so if sometimes when I don't log in, if you don't see me, don't think that I'm not gonna watch it. I'm watching it in the morning. So, and if I have any questions, I'll try to log in the next day at night, and then I'll tell you. I'll ask you the questions or any questions.
Fine, that is fine, no problem. Even your morning time also I'm available. At 5 I am available. So I mean my time 5 p.m. is going to be something like 7:30 for you. Earlier also I can be available. Because
no, if I watch it, it's going to be 7 a.m. So
okay, 7 a.m.
my time.
4:30. You are in the EST or which time zone is yours? Your time zone?
Sorry?
EST. Your time zone EST or CST?
CST.
Okay, so CST is going to be like CST is going to be 7 a.m. means 5:30. I think 5:30 my time. Even at 5:30 I am available.
Okay.
Fine. So if you have any questions, you can ask like that. You can even email me.
Okay, no problem.
Yes, Sandeep.
I like to know. Yesterday I write your day after yesterday the code which you. I have some questions on that. If you have a time, so I can show you maybe just some questions I have in it.
Shall we do? I mean, your morning time tomorrow around 7:30 a.m. your time. Is it possible, Mansur, for you to share at the time?
Which time?
Your time is 7:30. My time is going to be 5 p.m. Your time is 7:30, something like that. I think 5 p.m. of my time today.
Okay. I will wait for you tomorrow at 7:30 a.m.
Yes. Please. At the time we can do.
Okay.
Sandeep,
Okay, I will show you that. Okay, no problem.
Sandeep, you also try to attend, please, so we can discuss together those things. You also can understand something, what questions he is asking. Similarly, your questions, you also can raise 3 questions. So, because whenever you ask questions, you may be asking some question, that idea they may not get. Like this, we can be sharing. So, you also try to attend, Sandeep, please.
Okay, I will try.
5 p.m. IST, that is 5 p.m. IST, Indian Standard Time, 5 p.m. So in the US, in the EST, it's going to be 7:30 like that. So if you are available, then that will be fine.
Yeah, I'm gonna be. I'm trying to be available in sooner. Maybe starting Monday or so. But I'm still preparing questions, so I will be ready first.
Fine. Thank you.
So tomorrow is Saturday, so you are okay with that?
No, Saturday we don't have normally. Others they don't attend. So.
Oh, you mean Monday? I come Monday, right? Not tomorrow.
Monday. No. I mean Saturday fine. Saturday you can come online. I mean this session I am saying. This session we don't have.
Oh yeah, that's fine. But I come tomorrow for showing you that code.
Yes.
Okay.
That is okay. You can come as usual. Your Saturday morning. That's no issue. We can come, but this time we don't have. I am free.
Okay. That's fine. Okay. Thank you.